50 years ago, on April 3rd, 1973, Motorola engineer Marty Cooper made the first cell phone call from Midtown Manhattan using a handheld portable cell phone. He made history. Joining me today is NAE member Marty Cooper, a pioneer in the wireless communications industry. A graduate of the Illinois Institute of Technology with a degree in electrical engineering, he is the co-founder of numerous communications companies, many with his wife and partner, Arlene Harris, including Dyna LLC, where he currently serves as chairman. In 2013, Marty, along with 4 others, was awarded the NAE's prestigious Charles Stark Draper Prize for Engineering for pioneering contributions to the world's first cellular telephone networks, systems, and standards. Marty is an inventor, an entrepreneur, and executive. Welcome, Marty.
Thank you for having me, John.
Tell me a little bit about yourself. What attracted you to engineering?
Well, John, my earliest memories, I've known I was going to be an engineer. I recall when I was a child, maybe 5 or 6 years old, watching some youngsters with a magnifying glass burning paper using the sun, and I was enchanted. I just had to do that myself, so I got a Coke bottle, broke off the bottom, and tried to make a lens out. Of course, I failed. That was one of my first many failures. But that's what we engineers do, right? We experiment and learn from their failures. So except for a brief period where I thought I was going to be a physicist, and then I discovered that physicists have to learn chemistry. And it turns out I've never done anything successful in chemistry, including cooking. I'm a total failure at cooking, so, and I discovered that to be a physicist, you have to take continuing chemistry courses. So that really solidified my interest in engineering, and I've been doing that my whole life.
Now, you realize, Marty, that you're talking to a chemical engineer.
Well, right? I apologize. But
that's okay. No
the question is, are you a good cook, John?
Well, no. There are always stories about how someone came up with an idea. And it's been said you were inspired by Captain James T. Kirk using his communicator on the television show Star Trek, as well as Dick Tracy's wrist radio. So tell me, what was your inspiration? What spurred the idea?
Well, you're right about both of those. Dick Tracy was the real stimulus because he preceded Captain Kirk by many, many years. And I read Dick Tracy as a youngster continuously. But the real inspiration was when the Bell system came out and said that they were going to make a new thing called the cell phone. And this, to them, the cell phone was a car phone. Well, I was at Motorola at the time. We'd been building two-way radios for many years, and we were now ready to do something important. We discovered that people don't talk to people in cars. If you think about it, you spend maybe 5% of your time in the cars. The rest of your life, you are everywhere, and you should be able to communicate everywhere. And the real stimulus for making that phone call in 1973 was the desire to make the world understand that they were ready for personal communications, for having a device that was an extension of you, that made you reachable everywhere. Not everybody appreciates that, and gives you the opportunity to talk everywhere. And so we thought the Bell system was hung up in history and took them on. They were the biggest company in the world, John, and we were just a little company in Chicago, and we took on the Bell system, and the battle lasted over 10 years, and finally Motorola prevailed.
Yeah, we're going to get into that a little bit later. It was quite an inspirational story for you and for Motorola on that. But the idea that, your idea that people should be able to communicate one-on-one when they're walking or doing something else around, and not necessarily in a car. That was the basic concept, I guess.
It is. People are mobile.
Yeah.
They're naturally, inherently mobile. If you look around at the expressway every morning, it seems like nobody is where they want to be. Everybody's going somewhere else.
Right.
And to have a concept where you are chained to your desk or stuck in your home by a piece of wire is just not very natural.
Very interesting idea. My favorite quote is by the father of aeronautical engineering, Theodore von Karman, who said, "Engineers create the world that never has been," and certainly the cell phone was a creation that never had been before. It seems you've done that with the cell phone. Tell me a little bit about the journey, from conceptualization to development to dissemination.
Well, John, of course that's accurate, but the important thing about engineers is that they make people's lives better. Technology without the people part of the equation is not, it's just curiosity. The important thing about an engineer is that he makes the lives of people improved in one way or another.
Very good point. Well, how about the journey? Clearly you had to convince the senior leadership at Motorola, including CEO Bob Galvin, to support and push your idea forward. Funds must have been harnessed and cultivated from other parts of the company. You had to compete within the company. I think we call that intrapreneurial work. So tell me about that journey of convincing Motorola that they should invest in this.
Well, you're absolutely right. Motorola, to support your comment, invested $100 million over a period of 10 years in a concept where they may never have made a nickel. So the vision of my management at Motorola was exceptional. Bob Galvin, Bill Weiss, John Mitchell were the three senior executives, and they were all extraordinarily supportive. But you should know that their real interest was the Bell system. We're going to continue talking about the Bell system in our conversation. This is the old AT&T, had nothing to do with the new AT&T. And their vision, we thought, was terrible. They were talking about building car phones. Well, we had already gone beyond that. We were building handheld two-way radios that were making businesses functional that could not have ever operated before. So we knew that that was the way to go. But the real serious problem was the Bell system said, first of all, they wanted to have car phones. Second of all, they wanted to have a monopoly. And third of all, they wanted the ability to conduct all businesses, including what we were doing. So as far as my management was concerned, this was a threat to their essential businesses. We were the most profitable business at Motorola, two-way radios, and the manager was deeply concerned about that. So I've always been deeply appreciative of the fact that despite that, they still let me execute on this crazy dream of building a portable phone when the two-way radio at that time was a 20 or 30 pound machine. I mean, they were huge. And the idea of compressing all of that and much more into a handheld device was ludicrous. And the fact that they allowed me to take the resources of Motorola and put that together was an extraordinary experience.
And I believe Motorola also had to go toe-to-toe with the Bell system and the FCC, right? To get permission.
Yeah, well, it was a very complicated situation because the Bell system, at least when we started, was a great customer of Motorola. We built all kinds of equipment for them. But then we took them on at the FCC because you can't do any of these things without spectrum. And the FCC manages spectrum for the United States.
Now, explain spectrum. What do you mean by spectrum?
The radio channels that we talk on. Whenever you tune a radio to a different frequency, only one entity can operate on that frequency at any given place at any given time. And so for many years, since the 1930s, the Federal Communications Commission has had control over who can operate at any radio frequency at any time, at any place. And so the battle now was, in order to do cellular, you needed to have a really big hunk of radio spectrum, of these radio frequencies. The FCC had to make that decision, and of course, both Motorola and the Bell system were lobbying the FCC. Of course, the Bell system dealt with the FCC on a continuing basis, and they had 2 or 3 people assigned to every single commissioner. They had 200 people in Washington lobbying the FCC and the Congress. Motorola had 3 people covering the Congress and the FCC and every other agency. And somehow those 3 people took on the hundreds of people in the Bell system. And as I keep repeating in our conversation, we won.
The first cell phone call that you made on April 3rd, 1973, went to a senior engineer at Bell Laboratories, Joel Engel, also a member of the National Academy of Engineering. Can you summarize how that call went? The
concept of cellular was created at Bell Laboratories in 1947. It took 20 years for AT&T to decide it was time to do something with that. And they set up a group, Joel Engel was the head of it, to first announce to the FCC that they were going to do this, and they were going to build this new car telephone. And as I keep repeating, we decided to take them on. I woke up on the morning of April 3rd, 1973, ready to go on television on the morning show to announce our great achievement. And guess what? We got bumped. So our public relations people immediately found some obscure radio station that has disappeared in history who were willing to do an interview. And I told them, I want to be interviewed on the street. I want people to understand that this gadget we're demonstrating really is mobile, that you could be anywhere. And so we met in front of the New York Hilton on 6th Avenue, and we're strolling along. I was explaining how this telephone worked, and of course you have to demonstrate a functional device. I decided on the spur of the moment, you really didn't plan it, to call Joel Engel, who was my counterpart at the Bell system. So I reached in my pocket and took out my phone book. This will give you an idea of what the technology was like in 1973. Called Joel's office, and amazingly enough, Joel answered the phone. And I said, hi, Joel, this is Marty Cooper. He said, hi, Marty. I said, Joel, I'm calling you on a cell phone, but a real cell phone, a personal, handheld, portable cell phone. Silence at the other end of it. I thought I could hear his teeth gritting. So to this day, Joel does not remember that phone call, and John, I don't blame him.
Now, you didn't need to use AT&T's cellular network, right, on that phone call?
There was no network. We actually had to create our own switch, our own base station. Fortunately, the base station was across the street from the Hilton, so we knew it was going to work with that kind of a distance. But the entire system was built at Motorola. We built, in order to be a cellular system, you had to have more than one cell. And so we built 2 cells, one at the Hilton so we could demonstrate it, and another one at AT&T headquarters, where Bob Galvin, their chairman, demonstrated this thing in that same period to the AT&T executives.
Wow. Now that first cell phone is called the Brick.
Yeah, it was.
And it weighed, how much did it weigh?
The brick weighed about 2 pounds.
2 pounds.
Yes.
But it was a real achievement. How long did it take between the concept that you wanted, moving ahead when you got the agreement, to producing the brick? How long did that take?
Well, from the time that I persuaded the management that this demonstration would be part of our FCC demonstration, the team put this phone together in 3 months. But you should know that the technologies that they incorporated there were pulled from throughout the corporation. And the most important role that I had was running around the company persuading people to let go of their technology and let us use it in this phone. But think of the first that we did in this. The frequency we used was 900 megahertz. We were just learning how to use 450 megahertz at that time. And so 900 megahertz was an unattainable objective. And yet we managed to build a 900 megahertz thing. We needed a special antenna. We needed special semiconductors to do that. A cell phone has to operate over many frequencies. Up until that time, two-way radios used 2 frequencies, 2 channels, maybe 10 channels, but certainly not 1,000 channels. And so that first cell phone had a frequency synthesizer using an integrated circuit. Well, integrated circuits hadn't existed up until that point. So here was one of the first applications of an integrated circuit. And we had to put a duplexer in this phone at 900 megahertz. The duplexer in a typical car phone at that time was a box about this big, almost as big as our cell phone. And we had to incorporate a duplexer so that you could talk and listen at the same time. So the number of breakthroughs in that phone were extraordinary. People worked day and night. We had a team of 20 people on the job, besides all of the people in the rest of the corporation who did these individual contributions that made this phone work. They started at the beginning of the year in 1973. The idea happened around November, and by March, we had a working handheld portable phone.
That emphasizes the team work that's needed in an engineering system to bring all parts of the organization together. And I think in your book, Cutting the Cord, you talk about giving credit. You give a lot of credit to the man who designed the box. It wasn't easy to put all that stuff in a 2-pound box, right? And I think the industrial designer did a great job just to get that ready as well.
You're exactly right. Our industrial designer, a fellow named Rudy Krolop, ran the industrial design team for our whole division. And I gave him this idea in November. I said, Rudy, you're going to build a cell phone for me. He said, what's a cell phone? I said, well, let me show you. And I took the telephone off his desk and put the handset up, and I said, we're going to cut this wire, and what's left there is a cell phone. He took the job on. He assigned his entire team to coming up with the concept of what a handheld phone would look like. Of course, he kept charging other people for their time, but we actually ran a contest, and I bought all these fellows dinner at the restaurant across the street from Motorola in Schaumburg. And the phone that we selected was actually built by the way, they came up with 4 different phones, and every one of them is a phone that was years later executed by people like Nokia, Motorola, and all of the Japanese companies. So, but the one that we selected was the Brick, and the reason we selected that was it was simple. The last thing in the world we needed was for something like a slider or a hinge or something else to break in our first demonstration. So The selection was a very simple process. We took the very simplest phone and ended up with a brick.
Right. Very good. Fascinating story. 3 months. I mean, that's an incredibly short time to put all that together to create something that never existed before.
Yeah. The fellow that ran the engineering program was Don Linder. Don Linder was a curmudgeon. He wouldn't commit to anything that he didn't absolutely know he could do, and never did say that he would finish the program. He just said, well, I'll do my best, but I think it's impossible. And of course, he did achieve that.
So Linder did come through.
He did come through.
In fine fashion. Now, the first call was made in April 1973. How long did it take to make the first commercial handheld cell phones that you sell to the public?
Well, it took us 10 years. We started in 1973. Around 1980, we did the FCC allowed us and the Bell system to do a test. The Bell system tested car telephones, and we had portables. Our test was in Washington, D.C., and we had actually 1,000 portables wandering around FCC that we had constructed just for a test alone. You can imagine how much that cost us, John. Mm-hmm. The AT&T did this in Chicago, and has, of course, spent 10 times as much as we did to demonstrate what became an obsolete technology in just a few years. But the actual move from the demonstration we did in New York in 1973 to a commercial product that were actually sold to the public was 10 years. 1983, in October of 1983, the Bell system introduced their first car telephones, and in December of 1983, Motorola introduced the handheld portable phone that I named the Dynatac. Typical engineering name, stood for dynamic access, and it was a typical of my ability to predict the future. And we still don't have a total dynamic access telephone. We're still working on it, John, but.
Well, that's a pretty catchy name, Dynatec, even though it had a technical origin.
It was an engineering name, not a marketing name.
Yeah, I mean, you and I have discussed this to some extent in the past, but that's 40 years ago, and now look where we are with cell phones. We call them smartphones now because they can do a lot more, but they still connect people to people connectivity. Did you ever envision this going past just voice communication?
Well, of course, the cell phone now embraces a whole bunch of things that didn't even exist in 1973, like a digital camera and texting. But the most important change is that the cell phone is becoming an extension of the person. They haven't quite succeeded in that. The theory is that if you have a cell phone, you can personalize it by selecting applications. Well, that's very simple, John. All you have to do is look at 4 million applications and select the ones that are suitable for you. Kind of ridiculous. But the future is very obvious at this moment. The cell phone is already starting to incorporate artificial intelligence. At some point in the very near future, certainly within the next 5 to 10 years, everybody will have their own personal artificial intelligence as part of their cell phone. They won't have to look for an app. When the artificial intelligence will analyze your behavior, and when it comes to specific applications, it will either create an application or find one for you, and you won't even have to think about it. It's going to be there to serve you and to make your life more efficient.
Quite a vision there when you think about it, and quite a leap from 1983, really, when we had the first commercial cell phones. What about the finiteness of the radio spectrum. You've talked about this in the past. Will we run out of spectrum? We were talking about all these applications and opportunities. Is the spectrum finite?
Well, there's a theory, of course, that the spectrum is like a beachfront property. You know, you use it all up and there's no more. And yet, you know, when Marconi made the first commercial calls around the turn of between the 18th and 19th, the 19th and 20th century, he was the only person talking in the entire radio spectrum. He had no problem at all. But I made an observation that from the time of Marconi to the present time, we have doubled the number, the applications, the amount of radio spectrum that we use every 30 months, every 2.5 years. And if you work out the arithmetic, it turns out that we today are a billion times more efficient using the radio spectrum than Marconi was. So you wonder, how did that happen? How could you be? Well, the technology of splitting up the radio spectrum, of putting more and more information in it, squeezing it into a limited amount of spectrum has improved enormously. And the reality was that even today we are terribly inefficient at how we use radio spectrum. Just think about it, John. The way radio works today, you put up an antenna and you broadcast energy in all directions. You start out with the order of 100 watts, 40 watts, a huge number like that. And the amount of energy that your cell phone receives is a tiny fraction, a billionth of a watt. All that energy is being wasted, thrown out into this, and we have to learn how to be more efficient. And so I actually did some calculations and worked out a thing that I called the law of spectrum capacity, that the capacity of the spectrum to hold communications, to allow information to go from one place to another, has doubled every 30 months. And that's going to continue in the future. It has to, because there are so many things that we have yet to accomplish with this ability to communicate from one place to another. And so somehow the cellular revolution, and it certainly has been a revolution, but there's going to be another one that's going to solve problems of humanity, and it's going to demand huge increases in spectrum, and there are going to be some very interesting changes. For example, right now, if you are using a portion of spectrum, you get assigned your own personal spectrum. Well, that's kind of ridiculous. In order to achieve this objective of solving all the problems of humanity, we're going to have to share the radio spectrum. Well, that's going to be an interesting transition to do, because at the moment people pay billions of dollars for the opportunity to have an exclusive piece of the radio spectrum. That's going to go away. Well, I'm not sure the cellular operators are going to like that very much, but it's going to be essential if we in fact are going to solve all of these problems and transmit so much more information in the existing radio spectrum.
So we have Cooper's law then. Every 30 months we've doubled the capacity of communication.
Exactly.
And but when we talk about going forward and following up on your ideas of being more efficient in our use of the spectrum, we will need policy. We will need lawyers and government officials, and we need the public to see that this is what must happen if we're going to continue with Cooper's law of advancement. So it's a very good point there. You know, just to kind of finish up here, let me ask you, do you have, you were a young man back when you started with Motorola. I think you actually came out of the Korean War, right, with you were in the Navy for a number of years and then came to Motorola and got your advanced degree at Illinois Institute of Technology. But engineering, you know, there's a lot more. We have more gadgets now, more technology, but it's really the principles of engineering really haven't changed a lot. The creativity, systems, using science in the best way, and so on. Do you have any advice, based on your experiences, for young engineers, especially in innovation and how they should approach the innovation process?
Well, the most important thing with regard to engineering is to understand that without people, engineering has no significance, it has no meaning. What engineers do is solve problems that make people's lives better. And so my focus on engineering is always, how can I solve a problem that other people have?
It's also a point, it's not just solving problems, we create things that people didn't even know they needed. Right?
Yeah, but creating something that has no direct relationship to making people's lives better is just curiosity. Yes. It's just an exercise. But so the focus is not on the equations, on the creativity. The focus is on how do you change the human experience. And somehow in our society we seem to have forgotten that. And I didn't discover that, John, until I got a little more advanced in age. I still think I'm pretty young. I mean, you know, 95, I have years left to go. But the thing that I've encountered is my eyesight starts getting a little bad. Have you ever noticed what the instructions look like on every gadget that you buy? Yeah. It's microscopic print. So they think that we older people with bad eyesight, or even the younger people with bad eyesight, are to be dismissed. Well, that's not right. We ought to consider the human experience, but everybody, whether they're reading the instructions or they're using this machine, it has to be comfortable for all people. And so that's part of the example of how we have young engineers designing equipment for older people, and they're total failures. They will never really understand what it's like when everything is blurry, when you can't hear anything, you can't smell it. So I only suggest that, first of all, the young engineers should get passionate about what they're doing. If you're not passionate about what your life is, and I don't care whether it's engineering or any other thing, go do something else, because the experience of doing something that is part of your life, that's exciting, that gives you the satisfaction of accomplishment, is an experience everybody should have. But the most important thing for engineers is to remember that it's the people part of it that's hard. The engineering part is you can learn that in school, you can get experience on how to solve engineering problems, but the people part is hard because you have to put your mind into the mind of another person. That can be very difficult.
I like that. Engineering is about improving people's lives. That's a wonderful statement.
You said that in your usual way, much more concisely than I did.
No, it's great. That's Cooper's second law. So, well, Marty, thank you very much for joining me today, and congratulations on a fantastic career. You've made a difference in people's lives. You've improved people's lives. We all here are benefiting greatly from that, and so on behalf of society in general, thank you for what you've done, and keep going.
John, I always enjoy being with you, and you always stimulate me. Thank you.
Thank you. Thank you.